Hello, my name is Rina Dukor, and I am president and co-founder of BioTools Inc. The goal of this educational segment is to answer some of the questions I have encountered for the past 17 years while training hundreds of scientists on the use of FTIR spectroscopy for structure elucidation of proteins and peptides. FTIR is a well-established technique, but its use for conformational analysis of biologics has only recently been recommended and accepted by regulatory agencies worldwide. The use of FTIR for small molecules is straightforward, but biologics require more care and knowledge to properly measure, analyze, and interpret such spectra. Some other sources are either unclear or inaccurate in providing guidance. So in the upcoming segments, we will address a variety of questions that present some of the challenges, such as how to compare liquid versus solid formulations, what excipients and buffers interfere in your spectra, and how best to subtract them. What is the best way to measure low and high concentration samples? What is the difference in measurements in transmission, ACR, and diffuse reflectance? And finally, how does one compare structure? I welcome your questions and thank you in advance for joining me. The most important thing to consider is if your spectrum is correct. And there are several criteria that determines if the FTIR spectrum of a protein or a peptide is indeed correct. Now, if you took a look at this spectra, could you tell which one is considered a standard good spectrum? They all appear to have what's known as amide 1 and 2 bands that can help you determine the structure, but you can definitely see the differences between them. So if you start with the spectrum here on the right, you would probably say right away that there is too much noise. There is a lot of noise here compared to the signal, which is only at 0.004 absorbance level. So this spectrum, if you enhance the spectrum, as we will talk in future segments, you will see that the noise will not only be apparent in this region, but also in the very important amide 1 region. This spectrum has too much water vapor. Vapor exists in the atmosphere, and vapor absorbs in exactly the same region as your protein amide 1 and 2 bands, and they're the unwanted bands that you see on top of your spectrum. We will also talk about how to judge the good water vapor subtraction in the future segments, but definitely a spectrum like this is not appropriate for use in the structure analysis. Now, if you take closely a look at these 4 spectra, they look all fairly close, and many people will say they're adequate enough. But if you take a closer look, you will see that in this case, the baseline goes down around 1700 and comes up. In this case, there is an extra band at about 2150 wave numbers. In this case, the baseline goes up very, very rapidly. And in this spectrum on the lower right-hand corner, you have a very nice and flat baseline. Probably the most important criteria to judge if you have a good FTIR spectrum of a protein is the ratio of the amide 1 and 2 band. That ratio has to be between 1.2 to 1.7. If the ratio falls outside of that region, you either over-subtracted or under-subtracted your water or your buffer. Of course, it is possible that you have extra excipients that interfere in either one of the 2 regions, but that is for another segment, and you have to look very closely where those excipients absorb and how to subtract them. But as a general rule of thumb, if you have the ratio that is not within that 1.2 to 1.7, the spectrum is not appropriate. So if you take a look at this ratio is probably close to 1.1. The ratio here is probably 1.8, and the ratio here is 1.4, which is your perfect number. So to answer my initial question, this is the perfect FTIR spectrum is judged by 4 criteria: the ratio of amide 1 to 2, a flat baseline that comes up very slowly, no vapor bands, very good high signal to noise, and the presence, very important, the presence of other amide modes such as amide 3 and the CH stretching bands.
Welcome to BioTools, the recognized leader in advanced chiroptical instrumentation, protein structure analyzers, software, and services. We provide solutions for critical molecular structure characterization from basic research to finished products for biopharmaceutical and drug research in the academic, biotechnology, and pharmaceutical markets.